Hello everybody, it's time to study trigonometry. Okay, to understand trigonometry, we need to study some definition. Okay, very first one is sine, cosine, tangent, cosecant, secant, and cotangent. When you just listen to the names, it looks like a very special one, but actually not. Just a ratio of two sides of a right triangle. Okay? Here, when you're talking about right triangle, we have to understand that one angle of a right triangle is here, 90 degree here. So the other side angle here must be greater than 0 but less than 90 degree. Because the already one angle is 90 degree, the other angle must be greater than 0 but less than 90 degree. If it is 90 degree, actually make two parallel lines, so cannot be triangle. Hey, now sine is a ratio of two sides, which is suicide. From this angle, the best way of writing initial of a sine is here, starting from here, s, and sine theta. And when you write down initial of each function, ending part will be numerator here, y, and then starting side will be denominator here, r. Okay? That is definition of a sine. So sine is opposite over hypotenuse. And again, the best way of writing initial of a cosine c is here. Always think about from the angle. Okay, angle of this, cosine of this angle. So best way of writing cosine is here. And again, ending part over beginning side. So x over r. And tangent. The best way of writing initial over tangent t is from this angle. Okay, always start from this angle. T, tangent theta. So ending part over starting part will be y over x. So kind of a hint, memorizing definition, sine, cosine, and tangent. Now another three definition, cosecant. Cosecant is just reciprocal of sine. Okay, reciprocal of sine. So out of y. Secant is a reciprocal of cosine, so out of x. Cotangent, reciprocal of tangent. Okay, this one is a very basic definition. Just like when you study English, you need to memorize alphabet A, B, C to Z. Just like that. If you don't remember this definition, you cannot proceed trigonometry anymore. Now here, after we understand those definitions, let's study this one. Because this was a right triangle, according to Pythagorean theorem, two sides of a right angle, x squared plus y squared equal hypotenuse square. Remember, x squared plus y squared equal r squared. And again here, sine theta was y over r, cosine theta was x over r. Okay, we study now this one. So how we derive this, I will show you. Square of sine is here, square of cosine is here, and add that. Now common denominator r squared, so we can combine y squared plus x squared over r squared. Just before we saw x squared plus y squared is r squared. So this one same as r squared. So if you cross out, it will be 1. Remember, very important identity. Sine squared plus cosine squared is 1. Okay? Sine squared theta plus cosine squared theta equal 1. And again, two more things, if you remember, it will be very convenient. And later, in a test for identity problem, they use this definition a lot, so many times. You better memorize it. So, tangent squared theta, okay, according to here definition, so y squared over x squared. And then 1. 1 is always whatever same value over same value. Because the denominator is x squared, we can go 1 is x squared over x squared. Okay? X squared over x squared is 1, obviously. And then tangent squared is theta. So you add that. Then you can see this one reduced to x squared plus y squared over x squared, which is r squared over x squared. Okay? R squared over x squared. What was r over x? R of x was here. Okay? So, this one changed to secant squared. In the same token, you can try this. 1 plus cotangent theta equal cosecant squared theta. Cotangent, you can see here, x over y. So you make this one x squared over y squared, and then common denominator y squared. So you add that. And then you can see this one reduced to that. Okay? Very obvious. Okay. If you don't get this yet, stop video and study one more time and memorize very, very important definition of trigonometry. After we understand those definitions, and we need to understand two basic triangles. In right triangle, if one side is 30 degrees, and let's say just for convenience, hypotenuse is 2, then opposite side is half. If it is 30 degrees, always the opposite side is half of hypotenuse. So 2 and 1. And using Pythagorean theorem, 2 squared minus 1 squared will be 3 squared. 3. Okay, and then you put the square root sign. So the other side is root 3. And then you just apply definition. So sine 30 is opposite over hypotenuse 1 over 2. So sine 30 is 1 over 2. So you will use this one until you ended up using trigonometry theory at the school or after in your career. Okay? So remember, sine 30 will be 1/2. And then you can derive cosine 30 is adjacent over hypotenuse root 3 over 2. Tangent is opposite over adjacent 1 over root 3. Of course, you simplify it later, it will be root 3 over 3. And then cosecant is reciprocal of sine. So cosecant 30 is 2. Secant 30 is 2 over root 3. Cotangent 30 is root 3 over 1. Okay, remember this is a triangle. In right triangle, one side, one angle is 30 degrees, then hypotenuse is 2, just ratio-wise, okay, can be any value. And then opposite side will be half of that. Okay, and then the other one is root 3 times of opposite side. Okay. Don't forget 30 degree, 60 degree. So this one is 30 degree. Obviously we know here 60 degree. That's why from here we can get sine, cosine, tangent over 30 degree, 60 degree. Okay. And another triangle we have to remember is here 45 degree right triangle. 45 degree, then the other side must be 45 degree too. Then these two sides must be ratio wise 1 and 1. Then using Pythagorean theorem, hypotenuse come out root 2. Okay? I don't want to spend the time, so you can derive all those values here. Okay? Remember. Got it, right? But important is this triangle. Okay? Ratio over 2 right angle sides are 1 to 1. And then hypotenuse will be square over each side. You add it up and you get square root of that. So in this case, if ratio over 1 to 1, then hypotenuse will be root 2. Okay, remember. Very important. Okay, if you don't get, stop the video and try memorize and then go over. After we understand these two of them, to proceed to the graphing of sine, cosine, and tangent functions, we need to understand unit circle. Unit circle means when you make a circle here, length of a radius will be 1. That's why we call it a unit. Unit means 1. Okay, unit circle. And then very important is normally we use like a degree so far for angle, but when you make a here unit circle, length of a radius is 1, and you make arc length also 1. Okay, arc length 1. So from this ending point to the origin, you make a line, and these two lines make some angle. This angle we call 1 radian. 1 radian. So if you calculate this one, come out 57.29578. But you don't need to memorize all these values. Okay, just remember approximately 57 something. Okay, and then later, actually when you use this kind of value, you're going to use a calculator. So calculator show you angle right away. Okay, don't worry too much. Now from here, whenever we use a radian angle here, radian angle, then arc length, so we can calculate radius times radian angle. In this case, 1 times 1 radian angle make length of arc was 1. Okay, so once you use a radian angle, you can get the length of arc by radius times radian angle. Don't forget, this one is a radian angle. Okay, not degree. Not degree. Okay, have to be a radian angle. Then radius times radian angle, you can make length of arc. And another thing here is a very important one. Then how we get the area of this sector. Okay, and let's see here. To remember easily, from here you just straight out this one, making a right angle straight line here, such that this arc length and this length are equal. And then you make a line to the origin to make a triangle. Then this area of a sector and the area of a triangle are equal. Okay? Area of a triangle and area of sectors are equal. So area of a sector you can get by area of a triangle formula. 1 over times base times height. Base was r, height was r theta, as you saw over here. Then 1/2. Half times base times height, which means 1/2 times, okay. So area of a sector will be area of triangle, base of a triangle is r, height is r theta. And then use formula for area of a triangle. 1/2 times base times height, which means 1/2 times r square theta. This one is area of a sector. Okay? It's a very important topic. You need to memorize. Now, in unit circle, when we analyze a triangle, always make a triangle with the x-axis and hypotenuse. We never use y-axis. If you make a triangle like this, okay, then totally wrong. Always you make a triangle. Then, why we need to keep in mind this one? Okay, let's say, for example, just before at the beginning I told you angle of this angle must be greater than 0 but less than 90 degrees. But in our real life, we may have a sine 150 degrees or a sine 210 degrees, something. This one is obviously greater than 90 degrees. Then, what happened? But triangle cannot be greater than 90. Then, we have to use this unit circle. So let's go here. From here, you make 150 degrees. Okay, this definition gives you only information to find hypotenuse here, and then you use an angle in between x-axis only. Okay, if we have 150 degrees here, this one is 150 degrees, then because a straight line make 180 degrees, this one must be 30 degrees. So in other words, sine 150 degrees means sine 30 degrees in second quadrant. Okay, in second quadrant, you remember. In second quadrant, value of sine will be positive. Okay, positive. Why? We will go over right after this one very soon. So, sine 150 degrees will be same as sine degree in second quadrant. The second quadrant sine is a positive. So you should use sine 150 degrees will be sine 30 degrees. Okay, here we have a little longer explanation. Just to say that, okay? You don't worry. Now, and then here one more thing, very important one. Whenever we make a triangle, value of hypotenuse will be always positive. Always positive. And then the value of two right angle side, you go by coordinate. In this case, if we have a point here, value of x will be negative, but value of y will be positive. Okay? Remember that. Hypotenuse will be always positive. Value of two right angle side will be determined by coordinate value of this point. Now, then you can see in first quadrant, x value positive, y value positive, and hypotenuse positive. So sine positive, cosine positive, tangent will be positive. So all value are positive. And then second quadrant, hypotenuse is positive, y is positive, x value negative. Of course, negative here, right? Then sine will be positive, cosine will be negative, tangent will be negative, positive over negative. So in second quadrant, the sine only positive. And in the same token here, this is a positive, negative. So which one will be positive? Only negative over negative, right? Positive over negative make a negative, positive, negative over positive make negative. All region, negative or negative. So only tangent will be positive in third quadrant. And in the same way, you can see right away here, this is a positive, x value positive, y value negative. So quadrant 4, tangent on cosine only positive. Okay? all satanko. If you memorize that way, you may have a little bit, okay? Or at least you have to know how to figure it out, okay? In the first quadrant, all of them positive. That's why all of them will be positive. So this summary is here at the bottom. Okay, first quadrant angle is alpha. Second quadrant angle was beta. Okay, you see here, alpha, beta, psi, and theta. Okay. This one is just a summary of values. So first quadrant means angle values are alpha, all of them positive. And the second quadrant, angle value, beta, sine only positive. And third quadrant, tangent only positive, and quadrant 4, cosine only is positive. Okay, now we understand unit circle and right triangle, the relations, okay? Okay, now let's practice with a few questions here. Okay, after we understand the relation, what about the cosine 210, tangent 300, sine 330 degree, cosine 120 degree, tangent 150 degree? How do you find a triangle and how do you get the value? Okay? We just studied how to construct triangle in which quadrant according to this value here, right? And then we can determine value of each function, positive or negative, and the corresponding angle in between x-axis and hypotenuse. Okay, now you stop your video and then try solve these 5 problems, very simple one, and then after you finish, come back, okay? Stop video now. Maybe about 2 minutes. I think that you can get it. Did you try? If you try, let's go back here. The first one was cosine 210 degree. So these are 210 give you information only to find the triangle. So starting from here, you got 210 degree, and then you figure it out between x-axis and hypotenuse how many degrees. So obviously 20 here, because one straight line is 180. 180 plus 30 make 210. Then we have a triangle here in third quadrant with the angle between x-axis and hypotenuse is 30 degree. Okay? And then you go function. Cosine means what? From here, hypotenuse, adjacent over hypotenuse. Then just before we try, so cosine 210 is a cosine 30 degree in third quadrant. Third quadrant, the cosine is negative. Excuse me. So cosine 210 will be cosine 30 degree in third quadrant. Third quadrant value of cosine is negative. Okay? Cosine 210 is the cosine 30 degree in third quadrant. Value of cosine in third quadrant is negative. So you can get value. Cosine 30 was root 3 over 2 from 30, 60, 90 degree triangle. Okay? But all the values you remember. Okay? It's very convenient. And then you determine value is negative. So you could get the value here. Now, the next problem was tangent 300 degree. In the same token, you go from here 300 degree, then you leave 60 degree between x-axis and hypotenuse here. So which means tangent 300 will be same as tangent 60 degree in quadrant 4. Quadrant 4. In quadrant 4, only cosine is positive, all other one is negative, so you can determine, okay, tangent 300 will be same as tangent 60 degree in quadrant 4, which is negative. And then tangent 60 degree, you can get the value from 30, 60, 90 degree triangle, which is root 3. And the value is negative. Very simple, right? Okay, now next problem. Here, sine 330 degree. In the same way, you go from here 330 degree all around, then this leave 30 degree in between x-axis and hypotenuse. Which means sine 330 will be same as sine 30 in quadrant 4. So in quadrant 4, value of sine is negative. So sine 330 will be same as negative sine 30, which is negative 1 over 3 in quadrant 4. This value also from 30, 60, 90 degree triangle. Okay, you better memorize two basic triangle, 30, 60, 90, and 45, 45, 90 degree triangle. And another one is a cosine 120 degree. You go here 120 degree, and this means it leaves a 60 degree between x-axis and hypotenuse. So, just the same way, right? Cosine 120 degree will be same as a cosine 60 degree in quadrant 2, in second quadrant. So cosine 120. Value of cosine in second quadrant is negative, so cosine 120 will be same as negative cosine 60 degree. And again, from 30, 60, 90 degree triangle, we get cosine 60 is 1 over 2, and with the value negative. And I think this was the last question. Okay, tangent 150 degree. In the same way, 150, you go here. This leave a 30 degree between x-axis and hypotenuse. So tangent 150 degree would be tangent 30 degree in second quadrant. And then you decide what is the value of a tangent in second quadrant. In second quadrant, only sine is positive, all other one is negative. That's why we know tangent 150 degree will be tangent value 30 degree with negative value. So 30 degree. Again, from 30, 60, 90 degree triangle, we can get the value of tangent root 3 over 3 with a negative value. Okay. So this time, we study the definition of a trigonometry and 30, 60, 90 degree triangle and 45, 45, 90 degree triangle. And then we developed the unicircle and then we found a relation between right triangle and unit circle. And then whenever we have a certain function with the angle greater than 90 degrees or even negative values, then how we find the triangle in which quadrant depends the value of angle given. And then we can evaluate the value. Okay? So next time we will go over more of a unit circle and then how to draw the graph of each function, okay, sine, cosine, and tangent. And then later we study more of identity, and then we go over application of a lot of problems. Okay, now thank you. That's next time.